If you're building any kind of modern web app, you've probably heard the name Redux thrown around. It's one of the most popular tools for managing state. But what problem is it actually trying to solve? Well, today, we're going to pull back the curtain and demystify Redux, taking you from that feeling of chaos to the control and predictability it promises.
You know the feeling, right? We've all been there. You start a new project, everything's clean and simple, but then you add more features and more features. And pretty soon the state, all the data your app is juggling, it just feels like a tangled mess of spaghetti. You change something over here, and for some reason, something totally unrelated breaks over there. It really feels like you're just chasing bugs.
And look, this isn't some new, exotic problem. It's a fundamental challenge that comes with scale. What starts out simple and elegant inevitably gets more complex, and managing how data flows between all the different parts of your app becomes exponentially harder.
It's interesting to look at how older frameworks tried to handle this. A lot of them use something called two-way data binding. Sounds efficient, right? The view can update the data can update the view. But at scale, it created that exact tangled web we're talking about. You'd have data flowing in all directions, creating a cascade of side effects you could never predict. It got so bad that developers became genuinely afraid to touch anything.
So, to solve this mess, developers over at Facebook came up with a new pattern. They called it Flux. Now, Flux wasn't a library you could just install. It was an idea, a whole new way of thinking about how data should move through an application. And it became the direct inspiration for Redux.
Flux's solution was radical but simple. Get rid of two-way data binding completely. Just throw it out. Instead, it forced all data to follow a strict, one-way street. Every single change had to follow the exact same predictable path. This made everything so much easier to trace, to debug, and just to reason about.
And that brings us to Redux. Redux basically looked at the power of Flux and distilled it into this elegant little library built on 3 simple but incredibly powerful core principles. These principles are the absolute foundation of everything that makes Redux so predictable.
First up, a single source of truth. Instead of having bits and pieces of your app's state scattered all over the place, the entire state of your application lives in one single JavaScript object. This is huge. It means at any moment you can look in one spot and know exactly what's happening in your whole app. Debugging suddenly becomes way simpler.
Principle number 2, the state is read-only. Think of it like a museum exhibit. You can look, but you can't touch. You are not allowed to just reach in and change the state directly. The only way to make a change is to dispatch something called an action, which is really just a plain object that describes the change you want to make. This ensures that every single change is intentional and accounted for. And third, changes are made with pure functions. Now, to handle those actions, you write these special functions called reducers. A reducer is a pure function, and that term just means for the same input, the current state and an action, it will always, without fail, return the exact same output, which is the new state. No surprises, no side effects. This is the absolute key to making your app's behavior predictable.
Okay, so we've got these 3 big ideas: a single store, read-only state, and pure functions. But what does that actually look like when you put it all together? Let's walk through the full Redux workflow to see how it all connects.
So, let's picture a really simple example, a social media app. A user types out a brilliant new post, and they're about to hit that submit button. What happens next inside a Redux app?
Well, that data is going to follow that same one-way street we talked about. The click in the view kicks off an action. That action goes to a reducer. The reducer figures out the new state and gives it to the store. And finally, the store tells the view to update. Let's break that down piece by piece.
So step 1, that click triggers an action. And I want you to think of an action as just a messenger. It's a simple little object that has a type, maybe something like create post, and a payload, which is the actual data. In this case, the text of the post. The key thing here is the action only says what happened. It has no idea how the state is supposed to change.
That's where the reducer comes in. The reducer is like the manager on duty. It sees that create post action come in, it takes the old state and the new post from the action's payload, and then it computes a brand new state object with that new post added to the list. Notice I said brand new. It doesn't change the old state, it creates a fresh copy. And finally, we have the store. Its job is simple but absolutely essential. It takes that new state object from the reducer and makes it the one official state for the whole application. Then,
It sends out a notification to the UI saying, hey, something's changed. The UI components hear that, grab the new state, re-render, and just like that, the user sees their new post pop up on the screen. And boom, the loop is complete.
Now, I know what some of you might be thinking. That sounds like a lot of ceremony just to add a single post to a list. So the big question is, why? Why go through all this trouble? What's the real payoff here?
Well, the benefits are massive. First off, you get true predictability. You can actually understand your app because data only ever moves in one direction. Second, testability. Those pure reducer functions, they're an absolute dream to unit test. All of this leads to code that's way easier to maintain. But that last one, developer experience, well, that's where Redux pulls out its secret weapon.
Because every single change is a self-contained action and every state is a distinct object, you unlock a developer's superpower, time travel debugging. I'm not kidding. You can literally record user sessions, play them back, and step backward and forward through every single state change your app has ever made to find out exactly where a bug appeared. It is an absolute game changer.
But with all of this power, it's really important to take a step back. Redux is a fantastic tool, but it's not a silver bullet. It does add some extra code and complexity, so you have to be sure that the problem you have is big enough to warrant this kind of solution. And you don't have to take my word for it. Listen to one of the guys who actually created Redux, Dan Abramov. His advice is crystal clear. Start with the state management tools built right into your framework, like in React. Only reach for a tool like Redux when you start to feel real pain, when passing data around becomes a nightmare.
So here's the bottom line. Redux isn't something you should add to your project just because it's popular. It's a targeted, powerful solution for the very real problem of managing complex state at scale. So I'll leave you with this question to ask yourself. Is your app's complexity causing you genuine, undeniable pain? If the answer is yes, then Redux might just be the clean, predictable solution you've been looking for.